So start out with any last minute questions on chapter 1. Okay. So I will pause this. Or pause. What amazes me more is that I haven't heard them record yet. All right, so a lot of this is just recapping what we had done on Friday. This, with the brackets around the variable, usually I would just write the bracket with it, x bar bracket is equal to m. This is saying that the units of position is the meter. There are a lot of units that work for position, and any unit of distance would be the same. I put the SI here to talk about the standard unit is the meter. I'm not saying kilometers can't be used, but if someone talks about SI units, they're talking about meters. Meter is what is referred to as a base unit, or was referred to as a base unit. They switched things up a couple years ago, and they now have base quantities instead of base units, but M is still the international standard. And the advantage is if you're given a problem with everything is in SI units, then you know the answer is in SI units, and you don't have to keep track.
And that's standard international?
With a French accent.
With a French accent.
Standard international.
Standard.
Someone with a better French accent want to give a shot at it?
Standard. What was it?
International.
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 I took French for practice, but I'm not trying to do that.
I took it for far more than that, and my accent was never good.
Of course, they are in possession of the original meter,
Oh.
the standard, is it a piece of platinum or something?
No, it's not based on anything physical anymore, right?
Right, yeah, that's why they did some switching around, so that at this point, everything
Now it's in
is,
distance,
It's based on the speed of light, I think.
it is.
yeah.
And time is based upon the vibrations in an atom, and I mean, all the standards, they found kilogram was the last one. They finally now have something which is no longer dependent upon a physical object.
You wanna see something really interesting? On PBS, I think it was called Precision, and it was a 4-part series about measurement. And it started back with, how they originally started coming up with this stuff, and took it through history, all the different changes.
Cool, thanks.
They're really excellent.
Got it. I'm not surprised.
Yeah, all the way up to, what, he just mentioned, the part of the speed of light and the vibrating
Okay.
atom and the whole thing.
All right. We were last on acceleration. And I talked about if it's speeding up, velocity, acceleration are the same sign, slowing down, they have opposite signs, and sort of something a little bit deeper than that is that the net force, and I made a quick allusion to this, the net force is in the same direction as the acceleration. That is something that is hopefully solidified even more by the time we get to chapter 5, or I think it's 5. So if you think about it, if somebody pushes you in the direction you are already moving, so in other words, the force and the force and the velocity are in the same direction, then you will speed up. If someone pushes against you, you will slow down. So let's go through the plus minus 0. So I'm going to make that 0 right there. We'll make to the right positive. And I'm going to make this my starting point. And why is that 0?
That's where
Yep.
you decided.
Dr. Fox,
Yes.
can I, just for my brain, you don't have to do this, but if you would put the
starting point on the other side, I feel like my brain will have to default to the same thing we did last time, and I might have to like flip it.
Any objections?
It's very simple, it probably won't make a difference, but I feel like I won't go on autopilot if you put it on the opposite side.
Well, if you really want, sometimes your origin can be your starting point.
Yeah, well, we're gonna do enough of that, so I.
Yeah.
Break out of that. Well, the positive is still to the right, I'm not gonna change that one. Because if I have done to the left as positive, which is perfectly fine, except I'm been doing to the right positive so often that it messes with my head during this
Yeah.
exercise. Let's see, this is the starting point. All right, so, position.
Positive.
Positive.
Oh, 0, sorry.
No, position is positive.
Okay.
Yeah, we switched origin and starting point.
Right.
If you have issues with it, blame Anna.
It is okay.
No, it's good not to get stuck in a rut there. Thank you. No. All right. Displacement.
Positive.
Positive.
No.
0.
0.
There, I'm at the starting point. Number of people having difficulty code switching here. Velocity.
0.
Acceleration.
0.
0.
Why is my acceleration 0?
Because you're at your starting point.
Ooh.
Not
You're,
speeding up.
you're not speeding or slowing down.
All right. Gotta be careful with not moving, because that could have multiple meanings there. Some people view not moving as velocity is 0 when they're interchangeable, and legitimately so. However, just because you're not moving does not mean you're not accelerating.
Because you could be preparing to move?
Yeah, you're at that moment, because suddenly I start moving there, so I did accelerate. If I back up just a little bit. Acceleration is the change in velocity over change in time. If acceleration is 0 when you're not moving, that means your change in velocity is 0, which means your velocity never changes, which means you're never moving.
Is that the thing that you did with the like Usain Bolt? Like I'm faster than Usain Bolt?
Oh, that was more up in this region right here. That, I didn't get into the acceleration piece of that one. That would be, I have a marker right here. Ignore the handshaking. What is its velocity?
0.
0.
If I let go, what will the acceleration be?
Force of gravity.
It's along the right lines, wording was off.
It's negative 9.8. Yeah.
Why
The
negative?
Speed of, because it's gravity is pulling it down.
And
Okay, so positive is 9.8.
why is it positive then?
Because you told me
it's
so.
not.
I did not.
You questioned me the first time, now I'm questioning myself.
Yeah, that physics does that. It's a local
Yeah.
thing.
Absolute value.
Depends on what you assigned it
All right.
to.
So when I let go, the velocity is 0 at that moment I let go, but acceleration is not. But then the question back, I wasn't originally intending this one, but he originally said the acceleration was negative, and then he switched to acceleration as positive, which is correct.
Is it positive because it's
It's,
increasing?
well,
It depends on how you set up your.
Depends, yeah.
your
isn't it constant though? Because gravity's always a constant.
Yeah, but it can be positive or negative depending where you start or where your frame of reference is, right?
Yeah, or let's word it, depending on which way you want to make positive or negative.
Oh, so up would be negative because it's pulling on it, and then down would be positive because it's, not really pulling, it's just a force.
Or
If you say
up
so.
is positive and down is
Only
negative.
if you assign it as such.
Yeah.
Okay.
You
Down
could
would
have, when
be-
I said why is down negative, you could have just answered because I said so. There you go. You have the power to do this.
I'm not gonna
You're in
answer
control.
anymore, I'm just gonna let it go.
This is the problem with physics, you guys are like way too flexible.
Yeah.
Mathematics is more of like, this is this and that's it.
So we'll try to put everything to a math equation as quickly as possible so that it becomes inflexible. That's what I was hearing.
What? What was it?
You're saying math was inflexible. And
Yeah.
I'm saying we put everything into a math equation as quickly as possible, and that way it becomes inflexible. Do it for you.
Nail it down.
That's right. Now, you do need to establish what the signs mean. You do need to establish positive and negative, because that will tell you what the answer means. All right, so velocity,
Negative.
And again, that was part of the default over here. If I said, just say velocity, I'm talking about instantaneous. And so I didn't hear the, chorus of answers. I heard a mix of answers, so we'll try it again. Velocity,
Negative.
much better. As I stopped, my acceleration,
Negative.
Zero.
it's one of those two.
Whichever one you
Positive.
say it is.
Velocity was negative, so your acceleration will have to be positive.
Mm.
Yes.
Yeah.
All right, so now my velocity,
Positive.
and as I stop,
Negative.
Well,
Acceleration.
acceleration's negative.
Acceleration's negative.
oh yeah, but I guess I didn't actually ask the question. Thank you for reading my mind correctly. See, that's the way it's supposed to work for those who are having trouble with it. All right, so velocity again.
Negative.
Negative.
At the moment I stop and I turn around, at the moment that I've stopped,
Your
what was my acceleration?
Zero.
It was negative.
All right, well, I had for some of you who are struggling with it, the answer is either positive, negative, or zero. It's one of those three.
Well, it's zero because you stopped. You said the moment you stopped.
The moment.
But it's acceleration, not velocity. He's turning around,
Right.
he's changing direction, he still has to accelerate in the opposite direction.
So his velocity was zero.
So, no, it would, your acceleration would be negative because you're going that way, back positive.
No,
Showing the
because
direction of positive.
if he's going this way and his velocity is negative, then a positive force has to act on it, so his acceleration is positive. Right?
Yes.
Until you start going the opposite.
Okay.
No.
Yeah, unless we like.
All right,
define it.
so let's do it bit by bit, and then we'll do a number example.
Okay.
I'm going in the negative direction, my velocity is negative. I slow down. So my acceleration, based upon what I have written over here, I'm slowing down so they're opposite signs. So my velocity is negative, I slow down, my acceleration is positive.
Gotcha.
Now I'm speeding up in the positive direction. My velocity is positive, I'm speeding up, my acceleration is positive at that point.
Cause you're going, yeah.
Yeah.
So, but when I stop, again, this goes back to, we're dealing with change in velocity, as Isaac had said. What is the direction of the force? If something's going this way and then suddenly it's going that way, there has to be a force that's pushing it in that direction.
Right.
That slows it down at first and then shoves it back. The force is in that direction the entire time, so the acceleration is positive the entire time, even when I've stopped.
Okay. So if we were on the positive side and you were slowing down, it would be negative. But if something were to push on you from this side, pushing you negative, it would be negative?
Yeah.
Because the force is acting on it from the positive side going towards the negative side.
I issue with some of the language there. The force is acting in the negative direction in your example, and
Okay.
therefore the acceleration is negative.
Okay.
I'm kind of looking at this a little simpler. The acceleration is a rate. It's velocity that's a direction.
That made it
Acceleration
more
doesn't-
complicated for me.
Does acceleration necessarily have to have a, well, it's a vector, so it has to.
Yeah, it does have to have a direction, so, but velocity is the one that indicates which way an object's actually moving, okay? Lisa?
Yeah, is.
Velocity is dictating the direction.
Yes, of movement.
So when you say the rate of change of velocity, do you mean acceleration, or is that something else?
Acceleration is the time rate of change of velocity.
Okay,
What is the rate at which velocity is changing?
that's acceleration.
That's acceleration.
Acceleration itself doesn't have a direction, it's just because it's related to velocity that has a direction.
Acceleration, when
Is that safe to
we're
say?
talking, this acceleration, it does have a direction. It is a vector, as you mentioned this a couple minutes ago.
Yeah,
It does have a direction. But the meaning of the direction, that's the whole plus minus zero exercise, is trying to give you meaning of what that direction means.
right, the point I'm making is because it's a relationship to velocity, it's velocity that's dictating that.
Yeah, I think you could legitimately say that, or it's the change in velocity that tells you acceleration, direction of acceleration.
Right, is the change positive or negative?
Yeah. So if I start out with, I'm gonna squeeze it in right here. So if I have time and velocity, and I did this on the side of the board right after class, I think. 0, 1, 2. So start out going 15 meters per second, then 10 meters per second, then 5 meters per second, 0 meters per second, -5 meters per second, -10 meters per second. We'll assume that's lined up well enough. The change in velocity. What is the change in velocity during the first second?
-5.
Oh, it's duplicating units there. Apologize
So
for that.
is the change in velocity -5 or is the change in velocity 5? I'm picturing like the absolute value symbol, I'm thinking the change would be positive.
Oh, no, we're talking about, not asking for change in speed, although I think it'd still be -5 there. Change is always final minus initial, so it's 10 minus 15.
Okay.
The change here,
-5. -5. That's 5, isn't it?
No.
No, still
Because it's
-5?
still going down.
Okay.
-5 minus 0 is still -5.
Well, you can't go negative
-5.
velocity, can you?
oh yeah, we just talked
Oh,
about
yeah,
what
yeah.
negative velocity means.
Okay. It's always weird thinking of a negative speed.
Yeah, we're not talking a negative speed. The negative is purely a directional thing.
Gotcha.
All right, so, and it works out with the math too. All right, so my change in velocity is the same the entire time for each 1 second increment. My change in velocity is the same, and therefore my acceleration actually is the same. Because my change in velocity over the change in time is -5 meters per second per second. Or we generally simplify that to meters per second squared. But my acceleration is negative the entire time. During the first part of it, I'm slowing down. Velocity is positive, acceleration is negative. During the second part of it, after 0, I'm speeding up.
Which means your acceleration is positive at first and then it changes to negative.
Negative it's in the same direction the whole time.
But it's slowing down.
Yeah, when it's slowing down, the signs are opposite. So my velocity is positive.
Oh, sorry, that's what okay. I thought the like 15, 10, 5, for some reason I thought that was acceleration. Never mind.
Oh, no. Officially, I don't have acceleration up here.
Yeah.
What is that?
So in that table, you're saying that since it's slowing down, then the acceleration would be positive?
Yes, that is one way of looking at it, yes.
Okay, but the velocity would be negative, but the acceleration would have to be the opposite sign, right?
The velocity is positive the entire time. What this means right here is that just before you get to the 0, your velocity is positive this entire time, which means you're going in the positive direction. You have not changed directions. You're just moving in a straight line, but you're getting slower and slower. And then you stop, and then you start going in the other direction.
Okay. So the acceleration, I gotta get this right. So the acceleration would become positive once you switch signs? Is that what you're saying?
Acceleration is this negative the entire time here.
Because it's acting in the same direction the entire time. The acceleration is acting in the same direction the entire time, so it stays constant, negative.
You said the acceleration is in the same direction the entire time?
Is that correct?
That is correct.
Okay, and that's why the sign is negative for acceleration the whole time, because it's acting in the same direction the whole time?
Yes,
Okay.
yes. And technically, this is change in velocity. Now, acceleration is a vector. The only vector I have over here, if I can actually draw my arrow properly. The only vectors are acceleration and change in velocity. And so whatever the direction, the sign of change in velocity has to be the sign of acceleration. So time is not going to, I shouldn't say, for this class, we probably can assume time will never be negative, or change in time will never be negative. You can work problems in reverse if you want to, but I don't recommend it.
But we haven't mastered time travel yet.
Haven't we?
Right.
We're all traveling through time right now.
So, true enough. So the vector is the only one that can be positive or negative, and that's what dictates the sign of A? Is that what you're saying?
Yeah, yes, unless you want to do something funky.
the interaction between B and T, and when B is negative, A is negative.
Wait, I missed the last
If
bit.
it's delta V.
Change in time, we will assume is positive. We're gonna start a problem, we're gonna
Right.
look at problems from
It's always
some point
positive.
to later. So
So-
delta T is gonna be a positive number no matter
The
what.
delta V can be positive or negative.
Correct.
And is that what dictates whether A is positive or negative?
Yes.
Okay, so
Yeah, it's not-
as soon as V becomes negative, acceleration becomes negative.
So it's delta V becomes negative.
Delta V becomes.
Change in velocity.
Yeah. Now, one of the things to, oh, lost my train of thought there, sorry.
Right.
Let me bring it back. That's gone, I'll think of it in the middle of the night. I'll call each of you individually.
Is that alphabetically then?
Yeah. By second letter of your first name.
Just wanna set the alarm, just be ready.
Yeah, no, you know, it'll come when you least suspect it.
Not fair, it means you're gonna call me first.
Anna?
Why are we writing delta V with the vector symbol as opposed to A with the vector symbol to indicate acceleration?
Because the change in velocity and acceleration are in the same direction, that's why I just did delta V. I always looking at, what I wanted to look at right here was just looking at change in velocity.
Could you still have written the A with the vector symbol over it, it would mean the same thing?
It would be legitimate if I changed the units, because these increments are by 1 second, yes, it's -5 meters per second squared is my acceleration here. But if I had changed this to 0.1, 0.2, 0.3, 0.4, 0.5, my change in velocity is still the same, that doesn't change. My acceleration now is 10 times greater than it was.
Okay, got it, thank you.
Okay, Brooke?
I understood, then you threw the table up there and now I'm just lost. So